previous year question based on the binary number system. A number is expressed in binary 2's complement form as 10011, and we have to find out the decimal equivalent of the given number. So if a number x is in the binary and 2's complement of that number is given as 10011, so we have to find out the value of xs in this case. So remember one thing, if we find out the 2's complement of a given 2's complement number, we will get the original number. So again, if we find out the 2's complement of this given number, we will get the original number. So to find out the 2's complement, we have to find out the 1's complement first and add 1 to the LSB. So if we subtract each digit from 1, we will get the 1's complement. That is 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 1 is 0. This is going to be the 1's complement of this given number. Now we have to find out the 2's complement. For that we need to add 1 in the LSB. So 0 plus 1 is 1 and remaining bits will be as it is. So this is going to be the 2's complement of this given number, that is going to be the original number. So 01101. And now if you look at this number, since the MSB is 1, which means it has a negative sign, so the given number should have a negative sign, and magnitude can be found out from this value. So if we find out the magnitude, this is going to be 1 into 2 to the power 0 plus 0 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3. This is going to be 8 plus 4 plus 0 plus 1, that is equals to 8 plus 4, 12 plus 1 is 13. So we can say the number is negative and the magnitude is 13. So the given number is minus 13. For that, next question is the range of numbers represented by 8-bit 2's complement representation is. So here n value is 8. And it is asking us about the range of the 2's complement representation. So we know the range is between minus 2 to the power n minus 1 to plus 2 to the power n minus 1 minus 1. So for the 8-bit, it is going to be minus 2 to the power 7 to plus 2 to the power 7 minus 1. 2 to the power 7 is 128. So it is between minus 128 to plus 127. So the correct option is first option for the given question. Next question is an equivalent 2's complement representation of 2's complement number is. See, this number is already in 2's complement format and it is asking another representation for the given number. So remember one thing, the MSB here is 1, that denotes the sign is negative. So keep one thing in mind, this MSB can be extended since this is a 4-bit number. It is a 4-bit number, that is 1101, where remaining bits represent the magnitude and this MSB represent the sign. So if you want to write in the 5-bit format, it is can be written as 11101. So magnitude will be same and MSB can be copied to the further bits. If we want it to be represented by 6-bit, it can be written as 111101, where again last 3 digit denotes the magnitude and the MSB is being copied to represent it is a negative number. So this question asking us to find out the equivalent 2's complement representation of the given number, it is copying the MSB to the further bits. So if we represent this number by some 6-bit number, the MSB can be copied further. So the D option is going to be the right answer for this. This question is very important and asked in different exams many times. The 2's complement representation of minus 17 is. For that, we need to first find out the representation for plus 17. And then we have to find out the 1's complement and then we are going to find out the 2's complement. So representation for 17 is divide by 2. So this is going to be 2 8s are 16, remainder is 1. 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. and this will become 2 times 0 is going to be 0 and remainder is going to be 1. So this is going to be MSB and this is going to be LSB. So 17, or we can say plus 17, can be represented as 10001 in the binary format. Now we want to represent, we have to find out the 2's complement. For that, we need to subtract each digit from the 1. So it is going to be 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 0 is 1, and 1 minus 1 is 0. This is going to be the 1's complement of 17, and we have to find out the 2's complement. So we need to add 1 in the LSB. So 0 plus 1 is 1, and remaining digits will be as it is. So it is going to be 0, 1, 1, 1. But if you look at the option, none of the option is matching with the given answer, because it is asked, we have find out this answer in the 5-bit format. If we write the binary representation of plus 17 in 6-bit format, so if we write it in 6-bit format, this is going to be plus 17 can be written as 1001. An extra bit for the 6th bit can be taken as 0 here, because we want to write it in the 6-bit format. Now if we find out the 1's complement of this, we can directly write in by writing inversion of each bit. So this is going to be 1, 0, 1, 1, 1, 0. Now we have to find out the 2's complement. So simply add 1 to the LSB. This will become 1, 1, 1, 1, 0, 1. So the 2's complement that we have obtained is 1, 0, 1, 1, 1, 1. So if you look at the option number B, that is matching with the answer. So basically it was asking the 2's complement representation in the 6-bit format. Initially we find out by writing directly the magnitude, which was in the 5 bits. So that is why the answer was not incorrect, but it was not according to the